When you look at the wings of a Boeing 737, you might notice parts moving during takeoff and landing. These are not just simple flaps, they are part of a complex system of flight control surfaces, true engineering marvels designed for safety and precision. The Boeing 737 is one of the most successful airplanes ever built. Since its first flight many years ago, it has become a workhorse for airlines all around the world, flying millions of passengers safely to their destinations every single day. Its reliability is a testament to its brilliant design, especially the systems that allow pilots to control it in the sky. These flight control surfaces are incredibly important. Without them, an airplane would be unstable and impossible to steer. Imagine trying to drive a car with no steering wheel or pedals. It just wouldn't work. The same idea applies to an aircraft. These surfaces allow the pilot to guide the airplane through the air with great accuracy. They help the plane stay steady during turbulence and allow it to turn, climb, and descend smoothly. Every movement a pilot makes in the cockpit is translated into a precise reaction from one of these surfaces, ensuring the aircraft goes exactly where it needs to go. The primary flight control surfaces on a Boeing 737 are the ailerons, elevators, and the rudder. Each one has a very specific job to do, controlling the airplane's movement around one of three axes: roll, pitch, and yaw. In addition to these, we have spoilers, which play a crucial role in slowing the aircraft down and helping it descend. Together, this team of moving parts gives the pilot complete command over the massive machine. Understanding what each one does helps to appreciate the incredible engineering that keeps us safe in the skies above. So let's break them down. The ailerons are located on the outer trailing edge of the wings and control the plane's roll, or its ability to bank into a turn. The elevators are found on the horizontal part of the tail and control the plane's pitch, making its nose go up or down. The rudder, standing tall on the vertical part of the tail, controls the plane's yaw, helping it stay pointed in the right direction. Finally, the spoilers are panels on top of the wings that can pop up to disrupt airflow, helping to slow the plane down both in the air and on the ground after landing. Let's start with the ailerons. These are hinged surfaces located on the trailing or back edge of each wing, usually near the wingtips. Their job is to control the aircraft's roll. When a pilot wants to turn the plane to the left, they turn the control yoke in the cockpit to the left. This causes the aileron on the left wing to go up, and the aileron on the right wing to go down. This is called differential movement, because they always move in opposite directions to each other, creating an imbalance in lift that makes the airplane bank. This change in aileron position changes the amount of lift each wing produces. The wing with the downward-pointing aileron generates more lift, causing it to rise. At the same time, the wing with the upward-pointing aileron generates less lift, causing it to drop. This coordinated action makes the entire aircraft roll or bank into the turn. Once the desired bank angle is reached, the pilot can neutralize the controls, and the ailerons will return to their neutral position. The airplane will then continue to fly in a smooth, coordinated turn, all thanks to these clever surfaces on the wings. Now let's talk about the elevators. You can find these on the horizontal stabilizer, which is the small wing-like structure on the tail of the airplane. The elevators control the aircraft's pitch, which is the up and down movement of the nose. When the pilot pulls back on the control column, the elevators move upwards. This upward movement pushes the tail down and, as a result, the nose of the airplane pitches up. This is how a pilot makes the airplane climb higher into the sky, increasing its altitude. Conversely, when the pilot pushes the control column forward, the elevators move downwards. This action creates a force that pushes the tail up, causing the nose of the airplane to pitch down. This is how the pilot initiates a descent, guiding the aircraft to a lower altitude. This simple push and pull motion gives the pilot precise control over the airplane's flight path, whether it's for a gentle climb after takeoff or a steady descent for an approach to landing. The elevators are fundamental for controlling the aircraft's vertical movement and speed.